use the properties of logarithms to write the following expression as a sum, difference, or multiple of logarithms involving single variables. So basically what it wants us to do is it wants us to expand our logarithm. Okay, so remember that when we're expanding, we start with one natural log or log, and we want to kind of distribute the natural logs to each term inside of the log right here. So first we're going to distribute that ln to each term. So we have ln of x squared, and we're also going to have ln of e to the third. So we can't just have them like floating here, they have to be attached to each other somehow. So remember that when we are expanding our natural logs or our logarithms, if there is dividing inside the original problem, then that is going to translate into a minus sign between the expanded version or the expanded terms. Okay, so we have that rule down, and remember there's a third one. If you have an exponent in your terms in the expanded version, we can pull those to the front of each term, of each log, or natural log. So then that will give us 2 ln of x minus 3 ln of e. Okay, and you might be thinking that we're done because we've used all of our properties, but not quite yet. Remember our properties of logarithms. If we have ln of e, that is going to cancel out entirely, and you are just left with the 3. So your final answer is going to be, your final answer is going to be 2 natural log of x minus 3. So the first thing that I like to do is to look at everything inside of my log in the original problem and turn all of my symbols into exponents if I can. So the 100 and the x squared are fine, but this square root of y, remember that can be rewritten as y to the 1/2. So let's go ahead and do that because that'll make things a little bit easier in the long run. Also, sorry for my kindergarten handwriting. Okay. So remember that when we are expanding logarithms, we kind of distribute the log to each term. So we would distribute the log to the 100, to the x, and to the y. So if we write that out, we have log of 100. We're going to have log of x squared and log of y to the 1/2. Okay, so we can't just have them floating around. We need to have them connected by something, by signs, either plus or minus. And because inside our original problem they're being multiplied, that's going to translate into adding the individual logs when in the expanded version. So we're just going to put plus signs here between them. But we're not done entirely. Now we need to look at each of our terms and see if we can simplify them further using our logarithm rules. So with this first term right here, it's always kind of rule of thumb that if you have log of just a number and not any variables, you plug it into your calculator. If you get some crazy decimal that is like ongoing and isn't short and nice, then you want to keep it in this log form because that's going to be the easiest way. But if you do plug it into your calculator and end up getting like a whole number or something that's pretty concise, then you can go ahead and change that into that number if you would like to. So remember our base here, because it doesn't say it specifically, our base is 10. And we know that log base 10 of 100 is basically the same thing as, 10 to the what power is equal to 100. And we know that 10 squared is equal to 100. So this whole term is going to turn into 2, because that's that answer. Okay, and then the second term, we can't plug into the calculator because we have a variable inside the log, so it wouldn't make any sense to plug it in. but we do have this exponent up here. And what we can do with that, with our logarithm rules, is that we can pull it out in front of the log. And we can also do the same thing with the third term right here. Pull this out in front. So once we do that, we get 2 times log of x plus 1/2 log of y. Okay, and we can't simplify this any further or combine it any further, so that is our final answer. So we can go ahead and, for lack of a better word, distribute the log to everything inside of here. And so when you do that, you get log base 7 of 49. We get log base 7 of a to the 4th. And we get log base 7 of b to the 6th. Okay, and so we need signs in between these, and here's where it gets a little bit complicated. So inside of our original log problem right here, we have that these factors are being divided. So when you have that in your original log and you're expanding it, if your term or your factor was in the numerator in the original, then it's going to be a positive. It's going to be a plus sign in front of it. And if it's in the denominator, it's going to be a minus sign. So here our 49 was in the numerator in the original, so that's going to stay as a positive. And the a to the 4th was also in the numerator, so you're going to hook a positive or a plus sign in front of that one. But our b to the 6th was in our denominator, so you're going to put a minus sign in front of that log. Okay, so now that we have all of our signs to hold our logs together, then we can go ahead and look at each term individually and simplify as needed. So remember that log base 7 of 49 is basically saying 7 to the what power is equal to 49. And we know that 7 squared is 49, so this whole term is going to turn into a 2. Bring down that plus sign. So we can't simplify in terms of like numbers here in the second term because it's just a variable a to the 4th inside of our log. But we can use our logarithm rules or expansion rules and take this exponent and pull it out in front of the log. Same thing with the third term, take this exponent, pull it out in front. And so it's going to be 2 plus 4 times log base 7 of a. And then bring that down that minus sign. Whoops. And we're bringing the 6 in front, so it's going to be 6 times log base 7 of b. And we can't simplify numerically any further or combine logs any further, so this is our final answer. We're going to distribute that ln to every factor inside our parentheses and simplify as we go. So this is going to be, ln of 3. And remember, everything inside of our original logarithm problem is being multiplied, so that means we're going to be adding our terms in the expanded version. So we have ln of 3 plus ln of x squared plus ln of e to the 4th. So remember, we want to simplify each term individually if we can. When we plug ln of 3 into our calculator, we get a crazy decimal, so we just want to keep this as ln of 3. Plus, we can pull this exponent out in front of the ln, so 2 times ln of x, plus, same thing here, pull this 4 in front, 4 times ln of e, and since we have ln of e, and our base of our ln is e, then these are going to cancel, so you're just left with a 4. If you notice that up here, that these are going to cancel eventually, you don't have to do the whole step of pulling the 4 out in front, but sometimes it's better to do it just so that you don't get lost in the long run. But if you do notice that, you can go ahead and cancel them out up here if you want to. So then your final answer is ln of 3 plus 2 times ln of x plus 4.